This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The next thing I want to talk about for circles is tangents. A tangent to a circle is at right angles to the radius at the point of contact. This is formally written as each tangent is perpendicular to the radius that goes to the point of contact. So here I have a circle and I've drawn two tangents to this circle. If you take the point of contact and connect that point to the center, then that line will be at right angles to the tangent. So this line, blue line here, is at right angles to that tangent on top, and this purple line here is at right angles to this tangent over here. It should be noted that tangents can also be found when two circles meet at one point only. Circles can meet internally or externally, as we have met in our coordinate geometry course and if two circles intersect at one point only, then the two centers and the point of contact are collinear, which means they lie on the same line. So if we look at two examples of that, here on the left we have external tangent, so our two circles here and here meet at a single point, and through that point we can draw a tangent, and if we connect the two centers, we see that the point of contact also lies on that line at this point here. So our two centers and our point of contact are collinear. Just as in the external case, if we look at the internal case, our two circles in this case are not touching on the outside, but they're actually, one is inside the other, but they still only have one point of contact over here. And if we draw a tangent through that point of contact, and we look at the line containing the two centers and the point of contact, that line, not only is that line perpendicular to our tangent, but it shows that our two centers, here and here, as well as our point of contact, are all collinear, just as in the external case. The last property of circles I want to look at is to do with the perpendicular of a chord. If a line is drawn at right angles to a chord and this line goes through the center of the circle, it will cut the chord in two equal segments. So that means if we construct the perpendicular bisector of two chords, we can use this fact to find the center of a circle by finding the point of intersection between the two bisectors. So rather than seeing all of that in words, if we look at a picture here, we have a circle. We've drawn in two chords. We've said that a line at right angles to a chord and goes through the center, it will cut it in two equal parts. So conversely, if we cut it into two equal parts first, then we know that line that is perpendicular will go through the center. So if we construct our perpendicular bisector to, say, this chord up here, it'll cut the chord in half and be perpendicular, and we know somewhere on this purple line will be the center of our circle. So this is at right angles, and it cuts that into two equal parts. So next, if we take a second chord, say this one here, and do the same thing, then what we find is another line that must have the center on it. But if this purple line and this blue line both have to have the center on them, then that means the center of our circle must be at the point of intersection between those two lines. And that concludes our look at the properties of circles.